So in this question from the November 2008 paper 2, at first it gave us some experimental data and it's asking us to deduce the order of reaction with respect to A and to B. So from experiment 1 and 2 we can see that the concentration of A stayed the same, but the concentration of B was decreased by half. So we can say times 1/2 or divided by 2. And if we calculate the decrease in the rate of the reaction, we can see that it decreased by a factor of 4. So we will say that from experiment 1 and 2 it is second order with respect to B. And then for A, we can see that between experiment 2 and 3, the concentration of B was held constant and the concentration of A was doubled. However, there is no change in our rate of reaction. So it's zero order with respect to A. Then we can use our answers from here to deduce the rate expression for the reaction. So it would be rate is equal to the rate constant K and B squared, concentration of B. So then it's asking us use the data for experiment 1 to determine the value of the rate constant for the reaction. So from experiment 1 we have that our initial rate is 8.8 times 10 to the power of negative 4. And then it's equal to K, and we have 7.8 times 10 to the power of negative 2 squared because it's second order. And you can use a calculator for this part. And calculating this, we get that our answer is 0.145, and this is rounded to 3 significant figures. And then it also asks us the question for units. So for the units, we know that the unit of the rate is mole dm negative 3 and then minute to the power of negative 1, and the over the concentration of B, but it was doubled, so we would write mole squared dm negative 6, and there's no unit for time because it's concentration. So what we can do is bring this up, so we'll get that our answer is mole negative 1 dm 3, and minute will just stay on top, negative 1. So it would be K is equal to 0.145 mole negative 1 dm 3 minute negative 1.